Hello students, I am here today to explain some of the important compounds of alkali metals. We are going to include sodium carbonate, sodium bicarbonate, sodium hydroxide, and sodium chloride. First, we'll see the chemical name and common name of these compounds along with their formula. Sodium carbonate has the formula Na2CO3 10H2O. That means the chemical name of the compound is sodium carbonate decahydrate. This is commonly known as washing soda. Next comes sodium bicarbonate. Sodium bicarbonate has the formula NaHCO3. This is otherwise known as sodium hydrogen carbonate, commonly known as baking soda. Next is the turn of sodium hydroxide. Sodium hydroxide has the formula NaOH, and this is commonly known as caustic soda. Next is sodium chloride. Sodium chloride has the formula NaCl, and it is commonly known as rock salt or table salt. We shall see the preparation of each type of compound in this video. First one, sodium carbonate. It is generally prepared by the process known as solvay process. What do you understand by solvay process? In this process, we are bubbling carbon dioxide gas and ammonia gas through brine solution. What do you understand by brine solution? Brine solution is a dilute solution of sodium chloride. So it contains sodium chloride and water. In this brine solution, we pass ammonia gas. What is ammonia? It is NH3. Along with this, we also pass carbon dioxide. So the reaction occurring here is between sodium chloride, water, ammonia, and carbon dioxide. When it undergoes reaction, the reaction happens in different steps. First of all, ammonia combines with water and carbon dioxide to form ammonium carbonate with the formula NH4 twice CO3. The ammonium carbonate that is formed in the first step further reacts with more amount of water and carbon dioxide to form ammonium hydrogen carbonate, that is ammonium bicarbonate. Further, this ammonium bicarbonate reacts with sodium chloride, and what we get is ammonium chloride along with sodium hydrogen carbonate. In the next step, this sodium hydrogen carbonate, on heating, we get sodium carbonate along with carbon dioxide and water. Here I have represented only the skeletal equations. You have to balance it. Now, on further reaction, you find that this sodium carbonate is then reacting with water to form sodium carbonate decahydrate. Solvay process becomes important because it helps in the production of two industrially important compounds. One is sodium bicarbonate and sodium carbonate. Also, Solvay process also helps in recovering the ammonia that is used. So how is this ammonia recovered? By taking ammonium chloride that is formed in the third step, when it is treated with calcium hydroxide solution, we get ammonia back, and calcium chloride and water is produced along with it. So then the balanced equation becomes 2NH4Cl plus calcium hydroxide giving 2 ammonia, calcium chloride and water. Solvay process cannot be extended for the manufacture of potassium carbonate because potassium bicarbonate is too much soluble to be precipitated by the addition of ammonium hydrogen carbonate to a saturated solution of potassium chloride. Another important property of sodium carbonate is sodium carbonate decahydrate, that is Na2CO3 10H2O. Na2CO3 10H2O. When it is heated to a temperature around 375 Kelvin, it will produce sodium carbonate monohydrate by releasing 9 molecules of water. Further, on heating it above 373 Kelvin, you get sodium carbonate Na2CO3 in the anhydrous form by releasing water. That is, when sodium carbonate monohydrate, when it is heated further, you find that it results in sodium carbonate plus water. You find that the compound that is formed in the anhydrous form. What do you mean by anhydrous salt? It is the dry salt which doesn't contain any water of crystallization. So sodium carbonate in the anhydrous form, it is known as soda ash. So what is sodium carbonate in the anhydrous form? Anhydrous form means it is the dry salt which doesn't contain any water of crystallization. So dry salt of sodium carbonate is known as soda ash. Next is preparation of sodium bicarbonate. Sodium bicarbonate can be prepared by following the first 3 steps of the Solvay process. By the way, what is the Solvay process? The brine solution is treated with ammonia gas and carbon dioxide. So in the first step, what happens is ammonia reacts with water and carbon dioxide to form ammonium carbonate with the formula NH4 2CO3. Further, This ammonium carbonate reacts with water and carbon dioxide again to form ammonium bicarbonate. This ammonium bicarbonate, when it is treated with sodium chloride, it forms ammonium chloride and sodium hydrogen carbonate. If we stop the step here, we get the compound sodium bicarbonate. The second method of preparation of sodium bicarbonate is from sodium carbonate, Na2CO3. When it is treated with water and carbon dioxide, what do you get? We get sodium bicarbonate. It's a mild antiseptic used for skin infections. It can also be used in fire extinguishers. The next important compound of sodium is sodium hydroxide with the formula NaOH. It can be prepared in two different methods. First one, we'll see the electrolysis of brine solution. What is brine solution? It is sodium chloride solution. When it is subjected to electrolysis, so you know electrolysis happens in an electrolytic cell. The basic parts of an electrolytic cell consist of an anode, a cathode and an electrolyte. The electrolyte taken here is brine solution, that is sodium chloride solution. So then what happens here? When we pass electricity, you find that sodium chloride breaks down to form Na plus ions and Cl minus ions. At the same time, water will split to form H plus ions and OH minus ions. You can consider a competition that is existing between the different ions. That is, at the anode, that is the positively charged electrode, you find the negative ions, the anions reach there. You find that on considering the mobility of Cl minus ions and OH minus ions, you find that Cl minus ions are considerably smaller in size compared to OH minus ions. So you can think of Cl minus ions reaching there first. So then what happens is at the anode there occurs the oxidation, that is loss of electrons. Cl will lose the electron to the anode and you find that it will form Cl atom and electron will be released. So the loss of electron, it is known as oxidation. So at the anode you find oxidation occurs. We know that chlorine atom is unstable. So that means you find that 2 Cl minus ions are required so that it produces chlorine gas and 2 electrons are released. That is, at the anode, chlorine gas will be released. Now, what happens at the cathode? At the cathode, that is the negative electrode, you find that the ions that reach there are H plus ions and Na plus ions. Evidently, you find that the size of H plus ions are smaller than that of Na plus. The smaller the size of the ion, you find that it can move faster. So, mobility is more for H plus ions compared to that of Na plus ions. So, what happens there? You find that H plus ions reach the cathode, it receives electrons and form hydrogen. You know that hydrogen atom is highly unstable. So you find that two H plus ions are involved, which accepts two electrons to liberate hydrogen gas. With the result, you find the losers that are present. Na plus ions combine with OH minus ions, and it will form NaOH. That is, near the cathode, Na plus ions combine with OH minus ions to form NaOH. This method is known as Chlor alkali process, because the products involved consist of chlorine and sodium hydroxide. So this is a method for preparation of sodium hydroxide. The second method of preparation of sodium hydroxide is also electrolysis of brine solution, that is sodium chloride, in what is called a Kastner-Kellner cell. So what is special about Kastner-Kellner cell? Brine solution is electrolyzed using mercury as the cathode and carbon as the anode. That is, at the cathode, you find sodium ions reach there, it accepts electron, and in the presence of mercury, it forms sodium amalgam. So what is sodium amalgam? It is a compound that is formed with mercury. It is sodium amalgam. Now, at the same time, at the anode, what happens? At the anode, Cl minus donates its electron to form chlorine gas. So for that, you find that 2 Cl minus are required, and you find it will release chlorine gas along with 2 electrons. So you find that the reaction can be rewritten as Cl minus giving half Cl2 plus electron, because here we have taken only sodium ions. The sodium amalgam that is formed is treated with water. Then you find that it produces sodium hydroxide, mercury, and hydrogen gas. So this way also we can prepare sodium hydroxide. We get sodium hydroxide in the form of pellets, and these sodium hydroxide pellets are highly deliquescent in nature. So what do you understand by deliquescent substances? These are substances which absorb moisture from the air and turn into a pasty substance. So these are some of the important compounds of sodium. Finally, we discuss about sodium chloride. Sodium chloride is obtained by the crystallization of brine solution. You know, brine solution or seawater, it contains a lot of salts like sodium sulfate, calcium sulfate, calcium chloride, magnesium chloride, along with sodium chloride. So you find that these compounds, sodium sulfate, calcium chloride, and magnesium chloride, are found as impurities. Especially magnesium chloride since it is present in sodium chloride, you find that when it is kept in moist air, you find that sodium chloride will absorb moisture, or table salt starts absorbing moisture due to the presence of the deliquescent substance in it, that is magnesium chloride, and it turns pasty. So, to obtain pure sodium chloride, the crude salt is crystallized, that is, brine solution is heated to a very high temperature so that it reaches the crystallization point. We are filtering the impurities. All the insoluble impurities are first filtered to remove it, and then the saturated solution is then passed with hydrogen chloride gas when crystals of sodium chloride precipitates out, or it separates out. Calcium and magnesium chloride, being soluble than sodium chloride, remain in the solution. This is how we get pure sodium chloride. Thank you.